Hi there. Today we're going to talk about an introduction to programming with Python and in particular with how to use Spyder. So we're going to start by looking at this problem from projecteuler.net. And Project Euler has a bunch of different math problems that you can solve with coding. Super interesting. I highly encourage you to go check it out. Try some of them. This problem here is the one we're going to look at today. And so we've got a sequence of numbers that's defined like this. So if you have a positive integer n, if n is even, then the next number is going to be n divided by 2. Or if n is odd, the next number is 3 times n plus 1. And so we're going to use this rule. And if we see here an example, right, starting with 13, we get this sequence, 13, 40, 20, 10, 5, 16, 8, 4, 2, 1. It can be seen this sequence contains 10 terms. Although it hasn't been proved yet, it's thought that all starting numbers finish at 1. So for any starting number we give it, we're pretty sure that this sequence is always going to end at 1. And the question here is which starting number under 1 million produces the longest chain? So we're not going to quite answer this question, but we're going to give ourselves all the tools we need to answer the question. Let's talk about Spyder. So this is the Spyder interface for Python. It is an IDE designed to help make our lives easier when we're doing programming. So I've got a script here that's already been set up a little bit. It's given us a framework. And we can see over here on the left, we've got different files. This is part of our project. If we want to see other files, we can come over here to this side, click on the files, and then we can actually manipulate the folder tree here to get to any files that we might want. Other things that might be helpful, there's a plots tab here, and you can configure how you want your plots set up separately. And then lastly, a variable explorer. And this variable explorer shows us the variables that Spyder is keeping track of in its memory. And we'll see that very soon. So I've got a starting demo script here, and this has some functions. A function has this word def at the beginning. That means define. So we're creating this function and we're giving it a name. And the name I've given this function is iteration update. And then in the parentheses, that's what are called input arguments. Sometimes they're called parameters, but basically these are things that we're passing into the function. So that means it's a variable or just a fixed number or a string or something like that, and we're going to give that to this function. And then this function says, okay, you gave me a number n, and now I'm going to give you the answer that you want. It's very much like our standard mathematical definitions of functions. So here this is giving us n, and then the next, first a function always ends with a colon. That's how it knows to start the function. So then this next line we've got 3 sets of double quotes. And then we see a bunch of green text, and then 3 more double quotes. So that whole section is what's called a doc string. And a doc string is basically a way for us to tell both ourselves and everyone else what this function is supposed to do and how it's supposed to work. So here at the beginning, we've said what is it supposed to do. It's this function, iteration update, is generating the next number. So this is going to take in a number and it's going to give us out a new number. So the parameters, the input arguments, is n. And then we tell it it's going to be an integer, right? So we should expect to have an integer value coming in here, right? N is 25, 30, 31, something like that, not 0.68. And we're told n is the current number, so where we are right now in the sequence. And then we're going to return the next number. So based on what we saw here, we're going to use this information to return the next number in the sequence. Now, we've got this word here that says pass. What this means is that if we're not finished with a function, if we haven't started working with it, we can tell the function to pass over. So that means if you try to run this function, it's not going to do anything. If we don't have pass there, Python's going to generate an error, and we don't want that. So we're going to leave pass until we're ready to start writing the code. And we're ready now. So let's delete pass and let's start writing. And the first thing we need to think about is, what are the two different cases, right? And we're told if n is even, do one thing. If n is odd, do something else. So we have an if statement in Python that we can use, and it's quite simple. We type if something, and then quote, then we do something here. Now this question is, how do we know if a number is even or odd? And there's a really cool operator. It's called modulus. Here we use the percent sign to do it. And what this does is this gives us the remainder when we divide a number by another number. So 5 mod 3, sometimes we say mod, short for modulus. 5 mod 3, if we run it, that's 2. That means when we divide 5 by 3, the remainder is 2. Or if we did 7 mod 4, our remainder is 3. And so we can think about numbers in terms of mod 2, right? So what is 7 mod 2? Well, it's 1, because 7 divided by 2, the remainder is 1. But what about 10 mod 2? The remainder is 0. And it turns out that's actually true for any even number that we might pick. Maybe 432 mod 2, 0. So using this mod operator and something mod 2, that tells us if there's a 0, then it's even. If there's a 1, then it's odd. So if this thing is 0. Now I typed a double equals here because that means check. So you can kind of think of it like if something is equal, right? The equal symbol, sometimes we say it as is. And so we can say if this is equal to 0. And that may help you remember that when we're doing a test, when we're checking, right, when we're comparing, we need to use a double equal sign. So if this mod 2 is 0, we can write a comment with a pound sign or a hashtag, however you choose to do it. So this line is going to give us what happens if we have an even number. And if n is even, then we need to divide by 2. So if n is even, then the next n is going to be n divided by 2. Notice here, this is indented, right? It's a separate indent from the if statement. That means this is part of that whole thing. Similarly, if is indented from the function definition because it's part of the whole function. So that's what we want to do if n is even. What about if n is odd? Well, we could say, right, if n mod 2 equals 1, then do something. But we can also use the command else. And else happens anytime the first statement isn't true. And in this case, there's only two possibilities, right? Either n is even or n is odd. And so if it's not even, then it must be odd. And so if n is odd, then let's see what we do. The next number is going to be 3 times n plus 1. So n, the next one, equals 3 times n plus 1. Now the last thing we need to do, so we have our next number. But the last thing we need to do is we need to give that as our answer. So anytime we write a function, if we want to give an answer back, we have to use the return command. And so the return command says, okay, here's something, and I'm going to give it back to whoever asked me about it. And so we're going to want to return the next number. Now, let's talk about how we can actually check and see if we did our function right. If we come up here and click the green button, this is going to load our functions into Python's memory. That means we can now actually use these functions that we've written. So we'll see here, it ran the file and nothing happened because there was nothing to do, but it's now loaded it. So if we said iteration number of, let's do 44. What do we expect? We expect the answer should be half of that, right? Because n is even. Well, it would help if I could spell. Iteration update. Silly me. So it only works if you actually write the correct name. And so half of 44 is indeed 22. So that means it's working correctly for even numbers. So let's check it for an odd number, maybe 53. And so if we run it for 53, well, 3 times 53 is 159, plus 1 is 160. So it sure seems like this function is now working the way we want it. So now the next thing we have to do is we have to make a sequence. And we've got our function here, generate sequence, and we've got a starting number. And so we need to think about, well, how do we want to make this work? So the first thing, now that we're working with this function, we can delete the name pass. And we're going to need to read through our doc string to see what we need to do. Right? So we're starting with this start number, it's the initial number, and we want to return a list of numbers. So if we're going to need to make a list of numbers, the first thing we should probably do is figure out what's the first thing in our list going to be. And if we look, right, if we start with 13, the first number in our list is 13. So that means we should go ahead and start our list with the start number. And so the way you can define a list is you give your list a name. I'm going to call it mySeq, as in my sequence. And we then can start it, if we want it to just start out with one single value, we use these square brackets. And the starting value is going to be whatever my start number is. Right? I don't know what this is. It's kind of like a math variable, except it's a computer science variable. So my sequence equals brackets start number. That means this is going to be a list, and the only number in the list right now is my starting number. Now, assuming that the Collat's problem is actually true, that every number actually finishes at 1, which let's assume it is true, we're going to need to keep making numbers in our sequence until we get the number 1. So let's say that our current number, which is like the number that we just did, right? The number that we just added to our sequence is the start number, right? Because that's where we are. We're at the very beginning. And now we're going to write what's called a while loop. And so while loops are written like this. While, and then we have some statement, while something is true, and then we put a colon. So this while statement here, what this says is while this whole thing is true, while the current number, this exclamation mark means not. So while the current number is not equal to 1, then we should go to the next number in the sequence. And so let's figure out, well, what is the next number? The next number, well, we figured out how to do that up here, right? That's what this function was doing. So the next number equals iteration update based on our current number, right? The iteration update function takes in a parameter, and it's this value n. It's the current number. Well, currently our number is this current number function, or current number variable. So the next number is going to be based on this function of whatever number we give it. And we already checked to see that that function is working. So then the next thing we need to do is we need to add this next number to our list. And so the way we do that in Python, when we have a list, we can use the .append command. And what this is going to do is it's going to take something and it's going to just stick it at the end of our list. And so I want to append the next number. And now that line says, okay, I've got my list, and I'm going to add in this next number, and then I'm going to do whatever's next. So the next thing we need to do would be, right, we need to go back, and we need to check if we're at 1, and if not, we're going to need to keep going. So really, we're done with the while loop, except for one thing. We have to change our current number, right? Because that's now old. So our new current number is whatever the next number was. And now this is going to be what we check. And so we're going to see, is this new number not equal to 1? Then we should keep going. And finally, we're done the while loop. Once that current number gets to 1, it's going to stop the while loop. And we want to return the list of numbers, which is the variable mySeq. So now we can hit this green arrow, and hitting the green play button also saves your file at the same time. And now, let's see if this is going to work for 13, because we were given the answer for 13, right? So 13, 40, 20, 10, 5, 16, 8, 4, 2, 1. That sure looks right. Let's see. 13, 40, 20, 10, 5, 6, 16, 8, 4, 2, 1. All right. There we go. So now, that seemed to be working for that. Let's take a look at what happens. Let's try 26. And it shouldn't come as any surprise. Half of 26 is 13, and so we go from 26 to 13, and then the rest is the same. Now, if we wanted to save this as a variable for us to keep looking at, we could say x equals, generate the sequence. Let's start with 42, right? Because that's the answer. And now we can see here that up in the variable explorer, this has actually created this list for us, this x list. And so we can now use that and get some information about it and work with that in the future, right? If I wanted to see what X is, I could type X. So that's a brief intro to Python. Hopefully that was helpful. Thank you for watching, and look forward to seeing how you improve.